Hey guys, welcome back. Today we'll be continuing our deep learning series, and yes, it has been some time since I've recorded my last video. Might have been 2 days for you, but it has been longer for me. So I have been caught up in some stuff, but regardless, we are back in today's video. I think I wanted to do something special since this is like the fourth video which we are doing. I want to clarify four things about perceptrons that usually people get wrong, and people, it will confuse them a lot. So I want to clarify four things about perceptron which usually confuse people, and make sure that you'll never get confused about perceptron again. The reason I'm talking so much about perceptron is, once you have a basic knowledge of what perceptron means, you can move on to creating complex neural networks all by yourself with no additional effort. So if you haven't watched already, I highly recommend you go watch the previous video which I made a video talking about giving an intuition to perceptron. So I will link that video, or that video might show up right now on the top right. So go check that out. I'd highly recommend you to go check it out, because we have done a lot of demos. We have done a lot of talking about perceptron, how you can get a clearer idea about perceptron. So yeah, let's just get started. So we'll start with confusion number one. Okay, perceptron versus neural networks. Now, this is something which a lot of people have a lot of doubts about. Now, how is perceptron different from neural networks? Okay, so is perceptron the same as a neural network? The answer is no, it's not. Perceptron is a single unit of neural network. Neural network is like a huge, if you think of neural network like a huge stack of 100 blocks, perceptron is just singular block out of it. Okay, so you make a neural network when you add and combine a lot of perceptrons together. That is the only way in which you can make a neural network. Now you can think of it in this way: a singular perceptron is enough to make one decision, right? Yesterday we have seen, or the previous video we have seen, how we can use a singular perceptron to make a decision whether a person should be let in or not, right? In the same way, you can use a singular perceptron to make one decision, but you can think of a neural network as committee of these singular perceptrons. Okay, so it's like a council, it's like a group of people, it's like a group of people. They'll try and they make decisions to whether let them in or not, whether to let the person in or not. So when people usually mean neural network, they mean multiple perceptrons which are organized in such a way that they can make a decision. But when we say a singular perceptron, it just means one unit. So if you see multi-layer perceptron, people usually use the name multi-layer perceptron. It is just a fancier name for neural networks. Okay, so it's just multiple perceptrons. Got it? Okay, let's move on. The second confusion people have is, why did we talk saying that it only learns linear patterns? Now, what does this exactly mean? Okay, so linearly separable. We talked about what linearly separable means yesterday. What does this do? What does this mean, linearly separable? So, any data which is easily separated by just a singular line is called as a linearly separable data. Yesterday we have seen another example. Yes, by yesterday I mean the previous class. We have seen another example, botanist example, where we have seen that he can classify both red flowers and blue flowers based on by just taking a look at a singular line. Your brain draws a singular line to classify both red flowers and blue flowers. So that is a linear separable problem. Now, everyone says perceptron can only learn linear patterns or linearly separable data, but what does that actually mean in plain English? Now, this is what it means in plain English. It just means that you are supposed to differentiate between two sets of groups by just drawing a singular line. Now, this is good. That is why perceptron mainly, people usually talk about this as well. Perceptron fails in something called as an XOR problem. Now, what is this XOR problem? A lot of people might have talked about this. A lot of people might have known what XOR problem is, but in simple, it is like a classic challenge. Okay, you can call it a challenge. Now, why do people do challenges? They want to test their limits, right? So people wanted to test the perceptrons limits as well. So they created a challenge, and I mean, it's not a created challenge. They were testing it on a challenge, and they want to they want to use XOR. Okay, they want to predict the values of XOR using perceptron. Now, what is an XOR? XOR is a binary operation. Okay, XOR is a binary operation. It's called exclusive OR. If you don't know about binary algebra, OR is something which has if both the inputs, if either of the inputs are true, then it will result in a true. If either of the inputs is false, also it will. If the other one is true, it will result in a true. Only if both of them are false, it will result in a false. Now, exclusive OR is a binary operation. It has nothing to do with OR, but it has two inputs and it will give you one out. So it has something in this way. So let's say the inputs are A and B, and the output is A XOR B. Now, in this case, if both of the inputs are 0, it will be 0. If both of the inputs are 1, it will be 0. If one input is 1 and the other input is 0, it will be 1, and the same reverse as well. So this, when you're trying to plot it in a graph, it will look something like this. Now, this is how it would look if you plot this in a graph. Now, the blue points here represent zeros, and the red points here represent ones. Now, if you plot this in a graph, you can see there is no line which could actually separate these both classes. No matter how many lines you draw, there will always be some or the other discrepancy. Now, perceptrons are known not to solve this XOR problem. So, this is the main only reason people opted for multi-layer perceptrons instead of having a singular layer perceptron, because a singular layer perceptron can just draw a singular line, but it can't separate both zeros and ones from this. So this is called as the XOR problem. So that is the main reason we would need neural networks with multiple layers, so that each layer will learn different features and together they can handle complex. Next, if you have watched the previous video, a lot of you might have had a doubt as to why we are having a term called as bias. This is the third confusion I want to clarify, which is bias. Now, why do people talk about this bias? So let's just take two equations side by side. Okay, yes, in the previous video we have seen the actual equation of perceptron is w1 x1 plus w2 x2, right? And without bias, this is the equation, but if you add a bias, it will be like this: w1 x1 plus w2 x2 plus b. Now let's say I'm equating these both to zeros so that we can compare them as if they're some straight lines. Okay, so I'll show you this visually. Now both of them, you can agree that both of them are straight lines. Why? Because both of them have degree of 1, right? Their variables have degree of 1. Now if you think about it, what could be the values of w1 x1 w2 x2 for different things? Okay, so if x1 is equals to something and x2 is equals to something, we'll try to figure out some values. Okay, let's say w1 is equals to 1, w2 is equals to 2. Okay, so now you can see for the values of x1 and x2, whatever values you want to put, the line which you will plot in, if you say you take values of x1 and x2 and you plot a line, that line will always pass through the origin. Now this is not passing through the origin, this line is. Okay, so whatever line you're trying to draw with this one, it is always passing through the origin. So basically, whenever you're trying to make this, you're limiting your perceptron to always pass through the origin. Now this is a very bad thing. Why is this a bad thing? Because you're saying that this perceptron should always pass through origin. What if there's a better line which doesn't pass through origin, which can separate the classes, right? You need to take care of that limitation as well. That is the only reason you add another term called B in here. Now, what does this B stand for? It stands for bias. Now, this bias will help you shift this line away from the origin, so that you can shift it anywhere else you want, and it will give you freedom to move the decision boundary up, down, left, right, wherever it needs to be, so that it can fit it perfectly. Okay, so if you think about it in mathematical terms, this weights w1 w2, I'll just highlight it in red, w1 w2, they are some kind of slopes, right? Why are they slopes? Because they decide what angle you want the line to be in, and the bias is where the line is positioned. If you want the line to be positioned here and here, this is where the line is positioned, and this one is where the slope is. So in this way, you will easily be able to capture and identify where you can draw a perfect straight line. So bias is not some weird term; it's just intercept. If you think it's just intercept, and it will let you position your decision boundary anywhere in the space which you have. All right. So the fourth and final confusion a lot of people have is that perceptron is always learning. Okay, people think perceptron always learns from every single data point it has, but that is not entirely true at all. Perceptron, you can call it a mistake driven model. Okay, perceptron will only learn when there is a mistake happened, when it predicted something wrong. Now this is something really cool because perceptron, it helps train the perceptron very quickly. Now how does this work? If the perceptron has predicted that something is right, something is right, it will leave its weights and biases alone. But if it has predicted that something is wrong, then it will update its weights and biases in such a way that next time when similar problem occurs, it will be able to classify that easily. Now you can make that into an algorithm like this. So what you can do, you can make a prediction first, then whether check whether it is right or wrong. Now, if it is right, you can move on to the next example. But if it is wrong, you'll adjust your weights in such a way that next time when you encounter a similar problem, you'll classify it correctly. Now, this is a clear example of lazy updation. Okay, it will only do it when it needs to. It doesn't do it for every single test case. That is what makes perceptron easier to train, as well as it is easier to converge as well into a perfect line. So that is pretty much it for this video. I wanted to clarify four things about perceptron, which is very confusing to a lot of people. And with this, I think you have a very clearer understanding of what a perceptron will do. But if you guys did enjoy these kind of videos, make sure you go smash that like button. That will be very helpful. And in the next video, what we'll try to do is we'll try to talk about something which is very important, which will bridge the gap between perceptron and neural networks, which is called as activation functions. So I highly recommend you guys not to miss that one. And if you guys did like this video, if you guys watched till the end, that means you might have learned something new today. So if you guys did, make sure you go smash that like button, go subscribe to my YouTube channel, turn on the bell icon. I'll be trying to post a lot regularly. There has been some kind of gap between, but I'll try not to do that later on. And I'll see you all in another video.